try to get some good ideas, fleshed out, and then probably have an action plan moving forward. So as we know, this is a second annual event for ARA. So ARA is a project under the umbrella of the College of Engineering. We have had the great pleasure working with our dean, his team, and also many other departments in the college. So today it's we're very happy to have our dean Easterling with us. He's going to help us kick off the today and the forward. Yeah, thank you.
Appreciate that. Good morning. Good morning. First day of class, 8 o'clock class, 9 o'clock class. Everybody should be fired up and ready to go. It's a lot of activity on campus. If you happen to come through there, I'm not sure where you're all staying, but it's quite a change from about a week ago. So it's always an exciting time of the year. And I always say, you know, amidst the complaints of more traffic and the headaches and hassles, but if you're not excited as an academic about the start of a new semester, then you're probably in the wrong profession, right? So we're excited. So thank you, Hong Wei. Good morning, everyone, and welcome to Iowa State University and AraFest. I'm happy to be here to help kick off the event with you today. It looks, I've looked at the program, looks like you're gonna have a great couple of days. Indeed, you've already had some time, some of you, the past couple of days. So thank you all for being here. It's exciting to see representatives from so many agencies and universities and industry partners come together to advance ARA's mission. And what a critical mission it is, right? I don't have to tell you that. But to create reliable and accessible wireless networks that rural communities need, rural industries need, including a rapidly evolving agriculture industry, which I know you'll focus on a lot during the next couple of days. We're in the right place to talk about ag tech here on the Iowa State University campus, where our earliest roots, our deepest roots, and no pun intended, as a university are in the new ag technology area. The first name of Iowa State was, after all, the Iowa Agricultural College and Model Farm many, many years ago. While the Iowa Staters back then couldn't have imagined the possibilities and challenges of today's digital and precision ag, all throughout these years, Iowa State has shared the ARA commitment to new technology that is shared broadly with our communities and supports economic development. It's our land-grant mission afterward. It's really at our core. So I'm proud that Iowa State continues to be a research and innovation leader in agriculture and in computing. Tying these two together really bring two of our greatest strengths together. But of course, achieving ARA's mission requires combining many areas of expertise, working across disciplines, the so-called silos and organizations. And I want to thank Hong Wei and the rest of his team for bringing this group together. And I want to thank you one more time for being here at AraFest and for your collaboration with ARA. And welcome again to Iowa State University. I hope you have a great couple days. Thank you very much.
Yeah, thanks, Tim. Actually, I didn't even know our first name of the university has a model farm. I know we are trying to build maybe the new generation of model farm right now. Yeah, so ARA is part of the National Science Foundation, I guess joint National Science Foundation and USDA in collaboration with many industry partners. Some of them are actually here today. So the whole Power Program platform for advanced wireless research program is led by the Power Project Office. And we have had the pleasure of working with the office, and in particular, its director, Marie, in the past years, has been learning a lot. Also, he has always been very supportive, always joining us here too. So we have Marie with us. Please welcome Marie.
Well, good morning, everyone, and thanks for joining us here. I want to say congratulations to the team on the second phase of operations. It is a testament to Hung Wei and his big blue sky thinking, as well as to his team, which has made some of that thinking a practical reality at times when that seemed quite impossible. Just so everybody's aware, thanks to the Power program today, there are 4 advanced wireless testbeds across the country that simply did not exist before. And these are shared infrastructure resources that lower the barrier to entry for research and innovation in wireless networking. They provide system-level implementations with highly flexible and modular architectures, and they provide access to functions that are normally locked in proprietary systems to give enormous flexibility for experimentation and research. And Era specifically is unique in a number of different ways. It is the rural platform within our program. It is also exceedingly multimodal as a network. There are numerous programmable elements, from the software-defined radios from NI to the Skylark radios operating in TV white spaces with absolutely new open APIs that have not been available elsewhere. Era has also been pioneering in its use of open source stacks. As far as we know, Era is the only platform at scale that has a deployed end-to-end OAI 5G stack that goes all the way down to the UE code, which, again, not to get too far into the details, but that's, again, unique at scale for research purposes across the country. And then, of course, Era also has the 5G, commercial-grade 5G network powered by Ericsson radios as well for application-level research and specifically for precision ag and agricultural applications. For those that don't know, this second phase of operations has 3 new base stations, which I'm sure you'll see. It quadruples the geographic coverage of the Era footprint, specifically with a number of new long-haul wireless links. So I'm very excited about what the platform can do, the ways it can be used to learn more about the RF environment, to program networks, to add AI and ML to this wireless connectivity, and to develop technologies to make better use of spectrum going forward. So can't wait to see what the platform, the team, the researchers will do. And I want to welcome you. Congratulations to the team, and thanks again. I also would like to introduce our next speaker, Melvin Carter, who is the Division Director of Agricultural Systems for USDA NIFA. Is Melvin Carter in the room? Excellent.
All righty, good morning, everyone. As you heard, I'm Melvin Carter. I'm the Director of the Division of Agricultural Systems at USDA NIFA, and we live in the Institute of Food Production and Sustainability. So as I am sure you've heard many across the USDA say that we continue to face challenges as we try to ensure the prosperity of our rural and agricultural communities. This is where opportunity lies in shaping the future of U.S. agriculture. At the USDA, we have a job of tackling such things as climate change as well as food security. And I believe the answer to get to these answers is through smart technology. So in my division, Agriculture Systems, there are 2 main programs that you all will probably be interested in. Agriculture Systems and Technology, better known as AST, that's our engineering science programs. And we also have Agriculture, Economics, and Rural Communities, that's our social science program. I was discussing specifics for those programs and pretty much detail where broadband fits in those programs. So standard proposals for those programs, we fund those at anywhere from $650K to $800K, depending on if there are partnerships within your proposal that fits the $800K threshold. So AST, Agriculture Systems and Technology Program. This area emphasizes the interrelationships between agriculture system components to develop the next generation of engineered systems and technologies. For this reason, a broad list of topics encompasses this program. Just to name a few that relate to AraFest', they will include robotics, automation, energy efficiency, computing, precision, and geospatial technologies. In my opinion, and maybe something to think about, is that precision agriculture, the way I see it, has to one day transform into precision farming. So what does that mean? It means that it has to have the potential to cater to a specific farm, focused to a point of achieving it at the field or within the field level. So how many times have you seen a field outperform another, as well as have significant difference in yield within the sections of that same field? So we really need to make sure that as we grow this, I really do see it going into a place to where, with the right smart technologies, we can learn a whole lot we could learn a whole lot in a specific farm that will really help that farmer when it comes to production and profitability. We have two programs that may interest you. One is engineering for agriculture production and processing. It's in our RFA as program A1521. So this program area priority focuses on engineered devices, technologies, and tools to improve agricultural relevant plant and animal forestry systems. The second program is engineering for precision crop and water management. That's in our RFA as A1551. So this program focuses on engineered devices, technology, sensors, and tools to provide precision crop, orchard management technologies for targeted application for crop protection materials and improve efficiency of irrigation and nutrient use in agricultural systems. So a few predictions to think about. So what is the future of digital agriculture? According to the Global Ag Tech Initiative, the digital agriculture market is going to experience tremendous growth and is set to exceed $57 billion by 2032. This expansion is driven by the need for increased food production, sustainable farming practices, and the adoption of cutting-edge technology. Why precision agriculture? Based on a study by the Food and Agriculture Organization of the United Nations, precision agriculture has the potential to increase crop yields by 20 to 30%. So a look at current status of livestock farming. So according to research by Deloitte, the livestock sector uses 1/3 of the global arable land and 8% of available fresh water. It also largely is responsible for deforestation and biodiversity loss and contributes to 15% of the global CO2 emissions. Why smart livestock management? As you know, health issues and diseases can decrease the production efficiency in livestock by 33%. So implementing smart livestock management practices such as smart animal health can reduce the losses by at least 65%. And those key technologies that will be needed to get us there, artificial intelligence, broadband as to why we're here, cyber-physical systems, big data analytics, and cloud computing. But we must look at all of the hard-to-reach communities. We kind of had a discussion on that last night. I'm sure we'll have it in our panel. But going to the social side of it, we have a program called Agriculture Economics for Rural Communities, better known as AERC. This program supports rigorous economic and social science research that informs decision-making, policy design, and implementation, promotes rural economic development and prosperity, and thirdly, it looks to enhance quality of life and alleviate poverty. One program within that program that looks at broadband is rural economic development, where we examine the private and public returns to expanding broad infrastructure into rural areas, the barriers of broadband deployment and adoption. The program further looks at the potential relationship between the access to broadband and it affects on things like health, education, entrepreneurship, as well as job growth in the rural communities. So if you haven't thought about it, we have to make sure that we're not creating a digital divide. One such effort that we've been funding at NIFA is at Mississippi State University at the Southern Regional Rural Development Center, where they are conducting national listening sessions and conducting workshops, as well as working in the 1890 community to advance digital skills to the underserved communities to make sure that they are ready for this digital platform. Work being conducted in these communities noted that broadband was the most frequently noted infrastructure and public service need to support rural resilience. So let me share a statement that came out of one of the surveys that were done in the rural communities or one of these underserved communities. So we had one survey, which is one of our stakeholders, say, high-speed internet would help too, but there is not as much thinking being done about the end of the wire. Without educating and training for these technologies, they're just bricks in the wall between haves and have-nots. So please, just make sure that we're not doing this in a silo, that we're communicating with everyone. We need to make sure that we're communicating with those stakeholders because those are the ones that have to use it. We can't leave anyone behind. So science is always the foundation for resilience, and innovation of technologies is how we will advance and meet the challenges of tomorrow. With the global population expected to grow to 9 billion by 2050, it is critical that partnerships as we have here continue to drive us toward the next generation of productive and sustainable agriculture. Our mission at NIFA is to invest in and advance agriculture research, education, and extension to solve societal challenges. Are we doing that here? Our vision is to lead innovation across the nation through transformative discoveries, education, and engagement that address agriculture challenges. Are we doing that here? I think we're doing that here. I think we can check those two boxes off. So as I leave you, I challenge you to further impact the future by accelerating innovation and technology and putting science to practice. Your translation to research and to action solidifies our investment and provides solutions to those societal challenges. Thank you all for having me.
Yeah, thanks a lot, Melvin, for sharing setting the actual broad context for our discussion today. In particular, very much appreciate your mentioning of the socio-economic rural development aspect, which I think has been, especially for the technology community, like we are more used to somehow that's actually kind of get neglected, but it's actually essential to addressing the rural broadband challenges, as we say today. Hopefully we'll get to hear more from you in coming days. Yeah, so as Marie mentioned earlier, right, so POWER is a national major initiative that's actually consists of many platforms. It's led by USDA and also kind of the funding investment from USDA and NSF. We have several colleagues from NSF with us actually, Murad, Hasim, Ellen, and Sasha. Actually, the first time the NSF Communications Office joined us today. So thanks for coming to Ames. I know Ames is probably, it's hard to imagine where it is actually if you don't come here. Yeah, so Hasim is going to share a few words on behalf of NSF, please.
Hi everyone, I'm Hussein Abu Zaid. I'm a program director at NSF. As you know, the ARA platform was established in 2021, so quite a few years of hard work, and it's one of four or several, should I say, platforms for advanced wireless research, continuing NSF's tradition of funding large-scale, city-scale and platforms for wireless since maybe the inception of the internet. And ARA is, the other sister sort of platforms are Powder in Utah, Cosmos in New York, and AirPower in North Carolina. And they have, each of these has a different use case, and obviously ARA is about rural and agriculture. And I'm also joined today with my colleague Murat Turlak, who has been really meeting every other week with the Power Project Office and with the team quarterly, and you know, highly engaged in the making sure that the project is progressing. And also, these projects are managed from the Computer Network Systems Division. So we have our division director here, Dr. Ellen Zukura, in attendance. And I'm really happy to be here in person, because last year for phase 1 launch, I was here only remotely. For some reason, the flights are much easier. I don't know what you did, but the connections are much easier to find. So thanks for that. So as mentioned, you know, ARA's unique vision is realization of a living at scale, real world agriculture and deployment of wireless with agriculture and rural applications. And you know, over the last few years, it's been great to see ARA expand and realize from a concept on paper to an actual impactful program with a number of collaborations. And this couldn't happen without the support of the institution, institutional support, and local state government support, industry partners, many of them are here today, academic partners, as well as, you know, NIFA and other U.S. government agencies. So I want to share a personal note. So when I was an undergrad student, engineering, my university had an exchange program with Germany, and they took us there for 3 weeks in a bus, and we went around. I'm an electrical engineer, but I joined a group exchange with agriculture engineering department, and we went around farms. It was amazing to see how farms are run with the technology that was available then, and you would see a generation, like 3 generations of a family running a very high yield farm, with different focus, some focused on agriculture, different crops, cattle, and so on. So I'm looking forward to see, you know, 20 years later, and I'm really happy to see this happening here in Iowa, and the positive impact that it could have on the community, on the families, of course, on the environment, and so on. Of course, as a program director, following suit, I will not miss making an announcement. So we just announced at NSF a availability of a supplement. So if you have, for anyone who has an NSF award, an active NSF award, not just from our division, from any division at NSF, they can apply to additional funding to implement or validate their research on the ARA platform or any of the Power platforms that are active. They're all achieve general availability, so they're all available for the public for free to experiment with and implement their own solutions and see how they perform in the real world. Many of the functions are available even remotely from anywhere in the world. You can upload your ideas, and you don't need actually to email Hongwei before you do that. You can just apply. If you're using the standard functionalities that are available in the platform, you don't need to coordinate with the PIs of the platforms. You can just apply directly. Okay, so with that, I want to say congratulations to the ARA team and the partners and the community, and I look forward to the exciting program. Thank you.